My name is Dylan Darby, and today we're going to be presenting the car sales database along with my presentation partners Caleb, Trey, and Brandon.
Hi, my name is Brandon Fisher. I'm part of Group 12, and I will be talking about the business summary for our cars sales database. So, the business description and purpose for our business summary is that the car sales base is designed to serve both vehicle buyers and brand ambassadors at dealerships by centralizing essential sales data into a single accessible system. Pretty much the two main groups of our car sales database is consumers shopping for a vehicle and sales professionals working at dealerships. Purchasing a car is a significant investment, and consumers often face frustrations navigating multiple platforms to find reliable information. Similarly, dealership professionals rely on data to analyze performance and refine their strategies. So, two main problems that come from buying a vehicle or selling a vehicle is that buyers face information overload. They bounce between forums, websites, reviews, just to compare a couple models that they might be interested in. And sometimes the data can be misleading or confusing to the buyers. Similarly, sales professionals in the car sales business want performance data but don't have any centralized tool for analyzing trends or success factors. Um, so, our database simplifies this process by storing key information such as model, year, fuel type, transmission, body style, color, and historical US sales figures. By pulling data from trusted sources like goodcarbadcar.com, which is one of the biggest car review sites in the nation, the system reveals key factors that drive vehicle sales and provide users with actionable insight. Whether you're a consumer comparing base model options or a sales professional evaluating trends, the car sales database enables smarter, faster, and more confident decisions. So, our solution was to take attributes such as the make, the model of the vehicle, body style, safety ratings to compare to figure out what the best factors are for why people buy cars and why people sell cars. A couple benefits that we can take from this database is that buyers can find relevant information without confusion or wasted time, and sales teams can make data-backed decisions about inventory, marketing, and customer targeting.
Today I'm going to be discussing our business rules. These are the business rules we enforced while designing the database. Rules 1 through 3 ensure all vehicles are new, sold in the US, and in base condition. Rules 4 and 5 make sure the vehicles are from 2015 or newer and priced under $200,000. Rules 6 through 8 define relationships. Each vehicle has only one engine, one drivetrain, and one transmission. And we also require that each vehicle has both an interior and exterior color. Rules 9 through 11 continue defining how our vehicle data should be structured. Each vehicle must be assigned exactly one body style type, may have multiple optional features, and must have a single aggregated rating record. These rules keep the data clean, consistent, and easier to query across different categories.
Hi, my name is Caleb Abear, and I'll be going over our team's entity relationship diagram, some sample data and how we avoided repetition in our data, as well as some queries for our database dealing with database triggers. So taking a look at our ERD, as you can see we have a central vehicle table with several related tables surrounding it. The design that we went for is that each row in our database will correspond to a unique configuration of each vehicle in the database. So for example, a Honda Civic sedan would be a unique database entry separate from a Honda Civic hatchback. And furthermore, two Honda Civic hatchbacks with different engine configurations or something would each have their own entry in the database. And that holds true for any vehicle configuration. And these tables, as you can see, they mostly have one-to-many or one-to-one relationships with the vehicle table. That is except for the feature table, which actually has a many-to-many relationship, but uses the vehicle feature table as an intermediary. And when it comes to normalization, our database does meet the criteria for both first and second normal form. For example, all of our entries are atomic. We have a unique primary key for each row in each table. We have no partial dependencies, etc. We did realize towards the end of the project that we didn't quite achieve third normal form. And the main requirement of third normal form is to have no transitive dependencies, which is to say that columns can't depend on anything but the primary key. And unfortunately, we do have one transitive dependency, and that is the model column in the vehicle table, as you can see. And that depends on a non-primary key make. So with our current configuration, you could technically insert a Honda Camry or some other invalid make and model combination in the database itself. There's nothing preventing you from doing that. And to correct this, we would just need to add another table to store the models, similar to how we handle the other lookup tables like engine, interior color, things like that. So moving over to some sample data and avoiding repetition. So here we have our sample data, and this is querying the vehicle table and joining on the rating table. So we primarily avoided repetition through the use of foreign keys to these additional lookup tables, as you can see. And next up, we will take a look at some sample queries for our database.
So my first query I created was about the top 5 best selling vehicles. It uses a join between vehicles and sales tables, then aggregates these sales with sum and sorts by sales volumes in descending order. This matters in the real world for dealerships specifically because it can help identify which models are most in demand so they can efficiently stock and promote their best performing vehicles. And for consumers, it can help them see top seller ads and simplify their decision making. My second query is finding vehicles with above average safety ratings. This query uses vehicle with a rating, joins those together, and filters using a subquery that calculates the average safety rating. This can apply to the real world because for consumers that are wanting to buy the car that is the safest, it can help them identify more safe options quicker. And for dealerships, it can help promote top safety picks. Thank you.
For query 3, this query returns the total number of vehicles based on a specific combination of drivetrain and engine type. We joined the vehicle table with the drivetrain and engine tables, grouped by drivetrain and engine, and then used the count function to calculate the total vehicles in each combination. For example, you can see that there are 5 vehicles with a forward drivetrain and a 2.0-liter inline 4 turbo engine. Query 4 lists unique vehicle names combining make and model and shows the year each was sold sorted from the earliest to the latest. We used concat to combine make and model into one full name, then joined with the sales table to pull in the year sold. This helps us understand which vehicle models were sold and when, which could be useful for analyzing trends over time.
Hi, my name is Chiramidas, and I will be going over my queries. So my first query was that it listed a unique list of vehicle models based on how much they cost in descending order, and I used this by using the model, then the max price set as vehicle price from our vehicle table, grouped by our model, and then ordered by the vehicle price in descending order. Real world example usage of this would be, say if I'm a customer and I wanted to see the prices of the cars without going into the details of the cars. And say I wanted the cheapest car. So I would see like, okay, the Civic has the cheapest car, So now I might looking into the Civic to see if like, okay, this is something I want, all the details about it. So this would be just a great way to set where you are on your budget to see if you have multiple options or just one option. All right, and then for my second query, I did a query where it listed out the unique list of vehicles, make, model as their full name, along with the interior and exterior color combinations. Um, you know, I did this because, for a real world example, because say that I was a customer who wanted to find a black car, but I didn't know which cars those were, so I list this database out and I would see like, okay, the Ford F-150 has a black exterior color, the BMW 30i has a black color, the Mercedes-Benz C-Class has the black color, and so on and so on. But then say if I wanted a black interior, so then that would limit down my options to like, okay, so BMW has that 30i has that black interior, and the Mercedes-Benz C-Class has that black interior. So now I'll be like, okay, I know what my preference is. Now let me go into details of these cars to see which one I really want. Because we know as a customer, we're pretty picky on what we want and how we like things to look. So I thought this would be a great way for people to see all the color combinations and see if there's anything they like.
Number 7, I'm not sure what order it'll appear in, but this is the first one for me. And both of these will deal with database triggers. And it looks pretty long, but it's actually very straightforward. This one just performs a delete on the vehicle feature table whenever a vehicle is deleted. So as you can see here, it's deleting the vehicle ID where the vehicle ID equals old.vehicle ID out of the vehicle feature table. And the use case for this would be to ensure that we don't have any orphaned feature records that no longer have a vehicle associated with them. So for example, if a vehicle is deleted, you wouldn't want to have a bunch of features that only correspond to that vehicle or that vehicle ID once the vehicle is no longer there. So this would delete those records, and it would perform really similarly to like a cascade delete. All right, so next up. So this query is, or this trigger, I guess, is similar. It deals with an insert rather than delete. And so what it does is it inserts default values into the rating table when a new vehicle is inserted. So this could be beneficial to prevent newly inserted vehicles from skewing the ratings. For example, if the default were 0, it might drop the ratings of one branded vehicle quite a bit if you inserted a few new records. So this could be useful for preventing that.
Moving on to the reflection section. So after we finished our project, our group, we just kind of took the time aside to kind of see what went well with our project, what didn't work well, and just kind of see overall the project with our database. And so after completing everything and putting this presentation together, we actually realized there was a problem with our SQL file, specifically in the code and how 2 of our tables were populating. More specifically, the features and the vehicle features were turning up null, and that's because in our code we had written it to take 3 parameters in when actually it should have been taking 2 parameters. So when populating the data, our features table wasn't populating correctly, which then in turn affected our vehicle features. And then for Caleb, he had mentioned that we could have improved our database normalization to 3NF by adding a lookup table for our vehicle models instead of storing this directly into the vehicle table. And early on before, Caleb had mentioned this when going over the ERD, we could have added a lookup table, which would have made our table and our databases just look a little bit cleaner and just functionally work better than just directly sorting all our data in the vehicle table. And Brandon, he had mentioned about our scheduling. So since we are an online class, we didn't have a set time to meet after class or our our schedules kind of just differed week by week, whether we had work or classes or just stuff that we had to get done in our busy lives. But luckily enough, we were able to still find times to meet. Whether that was late at night or midday on the weekend, and we had constant communication with each other, just making sure that everybody stayed up to date. Everybody knew what they were doing, and what the assignment was asking us to do for this project. We mainly used Discord, which helped us a lot because we were able to upload files or ping someone to let them know or try to get their attention. And then Dylan had mentioned that we had to slightly change the data we were collecting and then our business rules. So, specifically, when we originally wrote our project, we said that our project was going to take in horsepower, but as we moved further into the project, we had to change that for it to not to take horsepower, just because we didn't see that it was feasible. But overall, everything stayed the same from our original proposal. Our business rules, we did have to add a few business rules, but nothing too major that affected how we were collecting our data. And thank you for listening to our presentation. And this was Group 12 with the car sales database.